Hello everyone, my name is Nachiket Patwardhan. I am from Group 8. The topic of our group project is vector space classification, and the part that I am currently doing is introduction to the classification types. So let's get started with it. The first thing is what is classification and its methods. So classification is basically a problem of identifying to which set of categories a new observation belongs to. It is done on the basis of training set of data is containing observations whose category membership is known. So, for example, if there is a data set where uh, data of mouses and its weights are given, and we have two subcategories, that is obese and not obese. So we will have to classify the new mouse if it comes into the picture, if it's obese or not obese. So for that we will have various methods. There are three methods actually in classification. First one is manual, second one is rule based, and the third one is statistical. So in manual method, it is basically accurate, but it is too expensive to scale. So for example, if we have millions of data, then it is very difficult to classify a new observation manually, because it may have a lot of subcategories, and depending on that it is very expensive or difficult for doing it manually, to assigning it or classifying it to a subcategory. The second one is rule based. In rule based also it is accurate, but it requires constant updating of the data. Like for example, if any new observation has come and we simultaneously found a new subcategory for the classification, then we have to uh, update it according to this new subcategory and so on. So it is also very uh, time consuming to update the rules every time. And the third one is statistical. Statistical, it requires some manual classification, but it is better than manual and rule based. So in this video we will be dealing with the statistical classification methods. The first one is Bayesian classification. In Bayesian classification, basically it is a statistical classifier which performs probabilistic prediction. It is based on Bayes theorem. uh, Bayes theorem, as you all know, it is very common if you are a computer science student. But this theorem basically provides a way to revise existing predictions or theories given new or additional evidence. So assumptions for this Bayesian classifications are: first, the classes are mutually exclusive and exhaustive, and the second one is the attributes are independent given the class. So if you want to do a Bayesian classification, then you will be using following statement, like for given features x1 to xn, we have to predict the label y. And for that, the good strategy will be, as I said earlier in the example, like if we have been given a data of mouse and we have to classify it as obese or not obese. So we will have to take the probability for that given mouse and do it accordingly. So coming to the next slide, it is the Bayes classifier. You know the Bayes rule, right? Bayes rule basically provides us the way to update our belief based on the arrival of new or relevant pieces of evidence. For example, if you are trying to provide the probability that a given person has cancer, we would initially just say it is a whatever percent of the population has cancer. However, given additional evidence such as the fact that the person is a smoker, we can update our probability, since the probability of having cancer is higher than the person uh, that the person is a smoker. This allows us to utilize prior knowledge to improve our probability estimations. So in this, as you can see, the Bayes formula, that is probability of A or B is equal to probability of A, which is prior, multiplied by probability of B over A, that is probability of B given A1 to AN. It is also called as likelihood, which is divided by marginal. Marginal is probability of B. Marginal likelihood is it is actually the total probability of observing the evidence. So we will be using this Bayes classifier also. It is one of the classification methods. The third one is Naive Bayes classifier. It is basically classification of it is a classification technique based on Bayes theorem. It also has an assumption of independence among predictors. If I have to elaborate it more, the naive Bayes classification, uh, for example, predict the most probable case for each instance. How we will provide that, like how we will classify that information. So a naive Bayes classifier basically predicts a class given value, given a set of attributes. For like for each known class value, we calculate the probabilities for each attribute condition on the class value. Then we will use the product to obtain a joint conditional probability. Then by applying the Bayes rule to derive conditional probabilities for the class variable. So this is regarding the naive Bayes classifier. In simple terms, naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any feature. So as you can see in the formula, P of x given y is summation of 1 to n P of xi given y. So these are the three classifiers. Um, Now we will move forward to the applications. First is the real-time prediction. Naive Bayes is an eager learning classifier, and it is sure fast, thus it can be used to make predictions in real time. Second one is multi-class prediction. Basically, it is for multi-class prediction feature. We can predict the probability of multiple classes of a target variable. The third one is recommendation system. The naive Bayes classifier and collaborative filtering together build a recommendation system that uses machine learning and data mining techniques to filter the unseen information and predict whether a user would be given a resource or not. So this was regarding the introduction to the various classifiers. Thank you.